How will humanity's story end? It is not a question we like to dwell on, but if history has taught us anything, it is that nothing lasts forever, not even us. Still, here we are, questioning, exploring, and looking to the stars. But here is the unsettling part. Why is it so silent out there? Where are all the other civilizations? Think about it. The universe is vast beyond imagination. Our Milky Way galaxy alone has over 400 billion stars, and there are at least 170 billion galaxies we can observe. Most stars have planets, and many of those planets are in the habitable zone, where conditions for life, like liquid water, exist. Life should be everywhere. So why do we not hear from anyone? The universe has existed for 13.8 billion years. Humanity has only been around for a blink of an eye. 200,000 years, just a fraction of cosmic time. In theory, an intelligent civilization could rise on one of those countless planets and spread across the galaxy in mere millions of years, a blink compared to the universe's lifespan. And yet, as far as we know, Earth remains the only place with life. No signals, no visitors, just silence. What does that mean for us? Have we missed something? Or is there a reason why intelligent life never lasts? Get ready, because the answer might reveal more about our own fate than we are prepared to face. The Fermi Paradox is named after Nobel Prize-winning physicist Enrico Fermi, who raised the issue during a casual lunch conversation in 1950. His questions have left scientists, especially astrobiologists, puzzled for decades. The search for extraterrestrial intelligence, SETI Institute in Mountain View, California, explains the paradox like this. Even a civilization with basic rocket technology and a desire to expand could colonize the galaxy relatively quickly. According to them, in just a few tens of millions of years, every star system could fall under its control. While tens of millions of years may sound long, it's extremely short compared to the galaxy's age, which is about 1,000 times older. Fermi died in 1954, leaving others to explore the paradox. One of them was Michael Hart, who in 1975 published an article in the Royal Astronomical Society's quarterly journal titled An Explanation for the Absence of Extraterrestrials on Earth. Some call this the first academic paper on the Fermi Paradox, although proving that is difficult. In the paper's abstract, Hart stated, "No intelligent beings from outer space are now present on Earth." He suggested the simplest explanation might be that no advanced civilizations exist in our galaxy. However, he noted that more research in biochemistry, planetary formation, and atmospheric science was needed to fully understand the issue. Hart proposed that if intelligent aliens existed, they might have visited Earth in the past, unless they started their journey less than 2 million years ago. Since there is no evidence of such visits, he argued that the most likely reason is the absence of intelligent aliens. But he also offered 4 alternative explanations. Space travel might be impossible due to physical challenges related to astronomy, biology, or engineering. Aliens may have chosen not to visit Earth. Advanced civilizations might have developed too recently to reach us yet. Aliens might have visited Earth in the past, but we failed to notice. In 1980, Frank Tipler, a physics professor at Tulane University, expanded on Hart's ideas with a paper titled Extraterrestrial Intelligent Beings Do Not Exist. In it, Tipler suggested that interstellar travel could be achieved using self-replicating artificial intelligence. These machines could copy themselves while traveling from one star system to another. Since no evidence of such machines has been found on Earth, Tipler concluded that humanity might be the only intelligent species in the universe. He even compared belief in extraterrestrial intelligence to belief in UFOs, saying both reflect hope for miraculous interstellar intervention to save humanity. Today, the search for extraterrestrial life continues to grow. Many scientific groups publish research papers on the topic each year, and the discovery of exoplanets has strengthened the idea that advanced civilizations might exist somewhere beyond Earth. So, here's the big question. Is there a lot of potentially habitable space out there? As I mentioned earlier, the universe is incredibly vast and ancient. Observations show that the observable universe is about 92 billion light-years wide and still expanding faster and faster. It's also estimated to be about 13.82 billion years old. This immense age and size might have given alien civilizations plenty of time to develop and expand, but the enormous distances between stars make contact incredibly difficult. When Enrico Fermi raised his famous question, astronomers only knew of planets within our solar system. That changed in 1992 when planets were discovered orbiting a pulsar, a dense leftover of a star. A few years later, the first planet orbiting a sun-like star was confirmed. Today, scientists have confirmed over 5,000 exoplanets, with new ones being discovered all the time. The sheer number of these alien worlds suggests that life could be common across the universe. As telescopes improve, scientists will be able to study the chemical makeup of the atmospheres of nearby exoplanets. But even the closest exoplanet, Proxima b, is about 4.2 light-years away. That's roughly 25 trillion miles, 40 trillion kilometers. The ultimate goal is to figure out how often rocky planets form in the habitable zone of stars, the region where water could exist on the surface. But habitability isn't just about water. Other factors like the activity of the host star and the planet's atmosphere are important too. In fact, the traditional idea of the habitable zone is now seen as too simple. For example, moons like Europa and Enceladus in our solar system are far outside the habitable zone but might still harbor life in their underground oceans. Despite these challenges, there seem to be many potentially habitable planets. A study in 2013 using data from NASA's Kepler telescope found that about 1 in 5 sun-like stars might have an Earth-sized planet in its habitable zone. A few months later, Kepler scientists announced the discovery of 715 new planets in what they called a planet bonanza. These discoveries were confirmed using a technique called verification by multiplicity. This method relies on probabilities, suggesting that objects seen crossing a star's surface or affecting its gravity are more likely to be planets than companion stars, which would usually destabilize the system. Sun-like stars, however, are only a small part of the stars in our galaxy. Most stars in the Milky Way are red dwarfs, small, faint stars that make up about 75% of the total. Astronomers have found rocky planets in the habitable zones of some red dwarfs, like Proxima b and the TRAPPIST-1 system, which is 39 light-years away and has 7 rocky planets. But red dwarfs are often unstable, especially when they're young. Powerful flares from these stars can strip away a planet's atmosphere, making it hard for life to survive. Scientists agree that more research is needed to understand how life might persist in these environments. Scientists now have access to advanced tools for studying the universe. NASA's Transiting Exoplanet Survey satellite, TESS, launched in April 2018, took over from Kepler, which retired later that year. By December 2021, the James Webb Space Telescope, with a $10 billion budget, began its mission to search for biosignature gases in the atmospheres of nearby exoplanets and perform other groundbreaking tasks. The European Space Agency plans to launch the Plato mission in 2026, which will add to these efforts. Meanwhile, 3 advanced ground-based telescopes, the Extremely Large Telescope, the Giant Magellan Telescope, and the 30-meter telescope, are expected to begin operating later this decade, allowing scientists to analyze exoplanet atmospheres. Another ambitious project, Breakthrough Starshot, aims to send tiny, laser-powered probes to explore Proxima b and other nearby planets. If progress continues smoothly, the first robotic mission of this kind could launch by 2050. These tools and missions are helping scientists grow their understanding of astrobiology, a relatively young field. For example, we still do not know if any planets or moons in our solar system can support life. Research on Earth has shown that microbes can survive in extreme conditions, suggesting that microbial life could exist on Mars or icy moons like Europa, Enceladus, and Titan. However, these worlds have not been studied closely enough to confirm this. The Fermi Paradox, however, is about more than just microbial life. To solve it, we need to understand how often life emerges on other planets and, more importantly, how often it evolves into intelligent life that can communicate or explore space. The Drake equation is used to estimate the number of intelligent alien civilizations in the Milky Way. According to the SETI Institute, the equation is written as N equals R times Fp times Ne times Fl times Fi times Fc times L star, where N is the number of civilizations in our galaxy capable of producing detectable signals. Ra is the rate at which stars capable of supporting life are formed each year. Fp is the fraction of those stars with planetary systems. Ne is the number of planets in each system with conditions suitable for lifefall, is the fraction of these planets where life arises. Phi is the fraction of life-bearing planets where intelligent life evolves. Fc is the fraction of civilizations that develop technology to send detectable signals. What might explain the Fermi Paradox? There are many possibilities to consider. One idea, based on research from 2015 using data from the Hubble and Kepler space telescopes, suggests that Earth might be an early developer in the universe's timeline. Scientists estimated that when Earth formed 4.5 billion years ago, only 8% of all potentially habitable planets that will ever exist had formed. This could mean extraterrestrial life might exist, but hasn't appeared yet, because the universe is still young. Another explanation is that life may not survive long enough to thrive. A 2016 study found that the early history of rocky planets is ideal for life to develop, sometimes as early as 500 million years after the planet cools and water becomes available. Earth's history supports this idea, with evidence suggesting life may have started around 4.1 billion years ago and was clearly present by 3.8 billion years ago. However, conditions suitable for life may not last. Events like a runaway greenhouse effect, similar to Venus, or extreme climate changes could disrupt life. As researchers Aditya Chopra and Charlie Lineweaver explained in their 2016 study published in Astrobiology, life on a new rocky planet in the habitable zone might face challenges like heat surges, freezing temperatures, and unstable conditions. These factors make it difficult for life to survive. Life may not be rare because it is hard to start, but because it is hard to maintain stable conditions in the first billion years. Another concern is that advanced civilizations might destroy themselves. Once a civilization reaches a high level of technological development, it may create existential risks. For example, during the Cuban Missile Crisis, humanity came close to nuclear annihilation. Similarly, climate change shows how industrial progress can threaten the planet by destabilizing ecosystems and accelerating ecological collapse. This idea connects to the Great Filter hypothesis, which suggests that advanced civilizations face a major obstacle, either before or after reaching technological maturity, that stops them from surviving long enough to explore and colonize the galaxy. While civilizations might develop technology to control their environment, they might also create tools or behaviors like nuclear weapons or environmental damage that lead to their collapse. This raises the question, is Earth's history a rare exception, or is self-destruction a universal pattern? There are other factors to consider. Planetary scientist Alan Stern, who led NASA's New Horizons mission to Pluto, suggested that the most common places for life in the Milky Way might be buried oceans like those on Europa or Enceladus. Life in such environments would likely never develop spacecraft or even know other worlds exist. Alien psychology might also play a role. Advanced alien civilizations may exist, but have no interest in communicating with or visiting us. Perhaps Earth isn't interesting enough to them, and they might only engage with humanity if we show enough intelligence and value to join a galactic community. Some researchers believe that intelligent aliens stay silent to avoid detection, fearing that revealing their presence could lead to their destruction or domination. This concern was echoed by Stephen Hawking, who warned against humanity actively broadcasting its presence to the universe. Finding intelligent extraterrestrial life is also extremely difficult. The universe is vast and ancient, while humanity has existed for only about 200,000 years and has been searching for alien signals since 1960. This makes the chances of our civilization overlapping with another detectable alien, one in time and space, seem very low. Most scientists think there isn't just one answer to the Fermi Paradox. Instead, a mix of factors likely explains the Great Silence. As our understanding grows, we may uncover more about what's behind it. If scientists discover microbial life on Mars, Europa, or elsewhere in the solar system, and that life is completely different from life on Earth, it would suggest that life isn't rare in the universe. Such a discovery would remove one possible explanation for the Fermi Paradox. Thanks for watching, and see you next time.